Good afternoon, students. Am I audible?
Yes, ma'am.
The screen is visible.
Yes, ma'am.
Sorry, I was in a meeting. We have a department meeting. So, what topic we discussed in the previous class, yesterday's class? We started with sorting and searching, general brute force approach. Then we discussed bubble sort, selection sort, insertion sort. So, any doubt in the basic concepts? I think we started with the divide and conquer technique, no? Yesterday.
Yes, ma'am.
Which topic we were discussing yesterday? Divide and conquer technique over.
Yes, ma'am.
Which topic we were discussing? It's divide and conquer technique. I think we started with this. Then we discussed. So the divide and conquer technique is if the problem is all produce united, it may look very big problem. If you divide the problem into sub problems, then you can easily solve the sub problems. Then we can merge, combine together to get the final overall solution. Same as lion and cow story. When all the cows are united, the lion cannot able to attack. If they are divided, then you can easily attack. So the logic behind divide and conquer problem is we'll take the problem statement, then we will divide the problem into sub problem using split. Then we will find out the solution for the sub problems, compute the sub problems, and get the final solution for each and every sub problem. Then merge all the sub problems together to get the sub problems answer. Then merge the sub problems together to get the final solution. Then we started about discussed about merge sort. In merge sort also we are using the divide and conquer technique. In divide and conquer technique, we have three stages. Every divide and conquer problem should follow the three stages, three steps. If you are applying the divide and conquer problem for the sorting technique, especially the merge sort. In merge sort logic, we are using the divide and conquer algorithm. In merge sort, our given problem statement is sorting problem. Sort a sequence of n elements into non-descending order. So the given n elements, unsorted elements must be sorted, and it should be in the non-descending. It means ascending order. So what are all the three stages we need to follow means we have to first divide, then we have to conquer, then we will combine the sub problems. So in divide stage, divide the given n elements sequence into to be sorted into two subsequences of n by 2 elements each. In conclude stage, sort the two subsequences recursively using merge sort. So first we will divide n elements into n by 2 elements, then sort the n by 2 elements subsequences, then merge the subsequences together to get the final solution. In combine, merge the two sorted subsequences to produce the sorted answer. If you take the advantages of divide and conquer technique, so in divide and conquer technique, the main advantages are solving difficult problems using divide and conquer is a powerful method for solving difficult problems by breaking the problem into subproblems, solving the subproblems and combining the results of the subproblem to get the solution of the original problem. And in divide and conquer technique, the parallelism technique is followed. It allows us to solve the subproblems independently. They allow execution in multiple processor machines. Difficult subproblems can be executed on different processes. So we are dividing the problem into n by 2, n by 2 subproblems, again n by 4, n by 4 like that. So when the subproblems are there, those problems can be solved at a time by using parallel processes. So the parallelism and pipeline processing is used along with the divide and conquer technique. And if you take the memory access, divide and conquer technique algorithms makes efficient use of memory caches. So we can make use of the caches. What do you mean by cache memory? What is cache memory? Memory caches. Anyone? This Tanvi Chaudhary. What do you mean by cache memory? Yes.
Achievement temporary memory, so we can access it faster all the time.
How it is faster compared to primary memory and secondary memory? On what basis? Where it is located?
Ma'am, it is located in our browser, that is browser or search on the internet.
So your voice very low. Why? Tell me. Why the cache memory speed is very high compared to the primary memory and secondary memory? If you take the memory hierarchy, the speed of which memory is very high? So the registers first preference, that's highest high speed processing will happen in the CPU registers. So we have the registers like B register, base register, data register, counter register, A, B, C, D registers. A is accumulator, B is base register, C is counter register, D is data register. So the if you do the processing with using registers, the speed will be very high. Then comes the cache memories, the temporary memory locations, then the primary memory RAM room, then the data stored in the primary memories, then secondary storage devices. So in the divide and conquer technique, we are making use of the memory caches to process the subproblems are small. So all the subproblems can be solved within the cache. So the problem, subproblems, and finding the solution for the subproblems and merging the subproblems together to get the final solution. Those things happens within the cache memory without accessing much slower main memory. The main memory is slower memory. The secondary memories are very, very slow memories. So the high speed memories are cache memories and CPU registers. So they are all the advantages of using divide and conquer technique. In divide and conquer technique, we are getting the benefits of solving difficult problems by subdividing and getting the solutions. And here the parallelism is used. So the parallel processing happens. The subproblems are processed parallelly, or the subproblems are running parallelly using different processes. And memory caches are used to subdivide the split, solve, and merge process. So they are all the advantages of divide and conquer technique. If you take the drawbacks of divide and conquer technique, here we are using the regression Recursive process is somewhat slow process because the same function has to be called again and again. So if you call many function calls, nested function calls, recursive function calls, then anyhow it call, return, push and pop the values from the subproblems. Stacks will be used. So that will take some time because of the overhead of the repeated subproblem call. The same subproblem is called through recursive functions. For some problems, divide and conquer technique become more complicated than an iterative technique. For example, to add n numbers in an array. Say the given problem is you add the given list of n numbers stored in an array. In that case, we need to add the first two numbers, then the second two numbers. Like that we need to add, then we need to merge, then we need to add overall. So that is somewhat tedious process compared to the normal iterative process. If you go with the divide and conquer technique for adding the given n numbers in an array, that takes more time than the normal iterative process of using for loop, just adding the first number with the second number like that. Total equal to total plus a of I. That using within for loop, that will function very fast compared to calling the recursive function. So these are some of the main advantages and disadvantages of divide and conquer technique. Any doubt so far what is divide and conquer technique? So in unit 2, we were discussing about two major algorithmic techniques, brute force approach and divide and conquer approach. Using brute force approach, we can solve the following problems: sorting, bubble sort, selection sort, insertion sort, and searching technique. Especially the linear search is algorithm is based on brute force approach. If you take the divide and conquer approach algorithm, this algorithm can be used for the sorting process using word sort logic and quick sort logic and binary search. These three algorithms, whatever given in your syllabus, for those three algorithms, we can make use of divide and conquer. So, what the general method of divide and conquer follows divide, conquer, and combine. And this is the logic. And if you take the merge sort as an example for divide and conquer technique, we need to follow the three steps: divide, conquer, and combine. So this is the major advantage and disadvantage of using a divide and conquer algorithm. Any doubt so far? How many of you gone through your Google Classroom?
Yes, ma'am.
Yes, I uploaded. You need to complete the first two lab exercises: linear search and binary search. First program, second program, merge sort, quick sort, and merge sort. Insertion sort, selection sort, bubble sort, and merge sort. So those two lab exercises you need to complete. Write the program along with the aim algorithm, program, sample input output and the results, the observation, scan and upload.
Ma'am, what is the challenging task?
Hmm?
Ma'am, what is the challenging task that's given in the assignment?
Challenging task this week I will give. Last 2 weeks based on that first lab program and second lab program. And for you, I gave one assignment also. For your batch, I gave one assignment one,
Yes, ma'am.
and unit 1 PPT and unit 2 PPT is given. Textbook is given, some reference material also given. We are in second unit now. So the third unit topics I will upload. And when you people are coming back to campus,
I'm first on, ma'am.
huh?
I'm first.
When your physical classes starts, offline
First July.
class. Hmm?
Ma'am, we are not sure because we have exams from third. So it's not sure if we will be going for classes on first and second. But Until now, as far as we know, we will be having physical classes on first and second.
Yes, I think Monday people are coming July 1st. Monday, Tuesday, you will be having classes, regular classes. And from 3rd July onwards, you have exam. Na? 3rd July onwards, you have exam. 3rd to 7th July. Am I
Yes,
correct?
yes, ma'am.
Right, ma'am.
Okay. So if you take the merge sort logic, the logic is very simple. Pseudocode is given here. We discussed these topics yesterday. No, merge sort we discussed yesterday.
Yes, ma'am.
We discussed already. Okay, if you take the merge sort, so to the procedure, so it is in pseudocode. Your function name is merge sort. It takes the following arguments: the list of n elements array, and p and r. They are the index variables. P is the lower boundary, zeroth index, and r is the last end of the array, that is size of the array. So the sort A of the array A of P to R, where P is the first position, first element, R is the last element, or the index position. A of 10 means A of 0 to A of 10. Total 11 numbers by divide and conquer technique. If P is less than R means P is your first zeroth index, R is the last size of the array. So if this condition is true, it means there are some elements in the array, then only we can apply the merge sort. If P equal to R means there is only one element. If P is greater than or P is greater than R means there is no elements. The array is empty. So if there is only one element, then only we can repeat the process. If there are no elements, we cannot repeat the process. Then Q equal to, we are using the index variables PQ or PQ or, where P is the first index, R is the last index, Q is the pivot element, or we can say it is the midpoint. Q equal to P plus R, first element plus last element divided by 2. So we'll get the midpoint. So the midpoint value is stored in Q. In the midpoint, that is Q, we are dividing the given list of n numbers into 2 n by 2 n by 2 subarrays. So we are calling the same merge sort function with the array A, and P is the zeroth index and Q is the midpoint. Zeroth index to midpoint. Again, Q plus 1 means the midpoint plus 1 to the last array index, or so we are dividing the given n numbers into n by 2, n by 2. For n by 2, we are calling the merge sort once again recursively. For the next n by 2, we are calling the merge sort recursively. So the merge sort is called within the same function, recursive call, 2 times. After through this merge sort, we will be getting the sorted list of the first array and the second, first of the array and second of the array. Then we will merge both the solutions, merge the array with the index variables P, Q, or P is the first element, Q is the mid element, R is the last element. Then we will get the final solution. So this process is repeated until the condition is false. Once the condition becomes false, then there are only one element in the array, then it will sort the element. So the logic is very simple and easy to understand. So any doubt in this merge sort pseudocode? This is the merge sort pseudocode. The merge sort pseudocode algorithm with variables, the array, P index and R index. P is the first element, R is the last element index. Input given to the merge sort is a sequence of n numbers sorted in a array of A. Output is an ordered sequence of n numbers. So we are giving an unsorted list of n numbers and we are producing an sorted array of n numbers. Within this merge sort, we are dividing using the midpoint and we are conquering, finding out the solution for the subarray, and we are merging, divide, concur, and merge. And we are getting the final solution by splitting the complex problem into smaller subproblems. Any doubt in the logic? The merge sort is an important algorithm. Any doubt in the logic of the merge sort or the pseudocode or the algorithm? How we are designing the merge sort means several techniques patterns for designing algorithms exist. The methods may be incremental approach or it may be divide and conquer approach. If it is a divide and conquer approach, the incremental approach means it's an iterative method, or we can say it is a brute force approach. It builds the solution one component at a time. In divide and conquer approach, it breaks the original problem into several small instances of the same problem and it results in recursive algorithms. So we are dividing, finding out the solution for the subproblems and merging the subproblems to get the original problem answer. Easy to analyze complexity using proven techniques. While using the divide and conquer approach, we are following divide, conquer, and combine stages. I think we discussed yesterday itself merge sort. In the first unit also we discussed merge sort. To take the merge sort strategy, we are using three stages. Divide stage, where the n element is divided into n by 2 elements of two subsequences. In concurrent stage, recursively sort the two subsequences. In combined stage, merge the two sorted subsequences to get the final solution. So n sorted, n unsorted elements, n by 2 unsorted elements, n by 2 unsorted elements. Now you apply the merge sort technique and sort the n by 2 elements. Again, apply the merge sort technique, sort the n by 2 elements. Now we are getting two sorted n by 2 elements. Again, you merge both the n by 2 n by 2 subsequences. Merge. Now you will get the sorted sequence of n elements. Divide, concur, merge to get the final solution. We already discussed. Say we are taking an unsorted array of 8 numbers. The given list of n numbers is 5, 2, 4, 7, 1, 3, 2, 6. Merge the first two numbers, sort, merge, and sort, merge, then sort with the two numbers, merge and sort the given two numbers. Again, merge these two subsequences. We are getting in 4 elements. The 4 elements you sort. Merge these two subsequences. They are already in sorted form. We are getting a subsequence of 4 elements. Now you sort the 4 elements. Again, you merge these two subsequences which are already in sorted form. Merge and sort. So in that way, we are sorting, merging. So any doubt so far? What is merge sort?
No, no.
So the input is in T of n numbers. Divide the n numbers into n by 2, n by 2. Again, n by 2 is divided into n by 4, n by 4. In that way, we are proceeding and we will find out the solution. Then we will merge the n by 8, n by 8, 4. We'll merge n by 8, we will get the n by 4. N by 4, n by 4 merged, we are getting n by 2. Merging n by 2, we are getting the n. So the given unsorted numbers, divide n by 2, n by 4, n by 8. So the unit level, the elements are sorted and merged. And we are sorted and merged, we are merging and sorting. So if you take the time complexity of this particular merge sort for given n numbers, we know very well while processing this we need n iterations, n iterations, n iterations. So the overall time complexity of merge sort is Cn log n plus 1. So it is equivalent to C is an error factor, n log n plus Cn can be represented as n log n. So the merge sort time complexity is big theta of n log n. Any doubts so far? We discussed a quick sort yesterday. No?
No, ma'am.
Any idea what is quick sort? Why we are calling it as quick sort? As we discussed, the data structures and algorithms is almost 80 years old subject. When the computer science started, the logic is represented using data structures. So the words, the various algorithms, techniques, all those things are, they are taken the typical keywords. So what is the meaning of quick? Quick means very fast. So the algorithm is very fast compared to remaining all algorithm techniques. So it takes less time as well as less complexity. Space complexity and time complexity is very less compared to the other algorithmic techniques. So they are calling it as quick sort. The same way merge sort means we are merging and we are sorting. So we are calling it as merge sort. In quick sort also we are using the divide and conquer sorting algorithm. As it turns out, merge sort and keep sort, although order of big O of n log n in the time complexity. For merge sort, the time complexity is big O of n log n. They have fairly large constants and tend to move data around more than desirable. Equal key items may not maintain their relative position from input to output. Here, without considering the relative position, whether the given list of elements is in sorted form, partially sorted form, or reversely sorted, or randomly placed, depending upon that, the time complexity and space complexity will differ. But irrespective of the relative position of the elements, the quick sort takes very less time compared to the remaining sorting techniques like insertion sort, selection sort, merge sort. So we are calling it as quick sort. We introduce another algorithm with better constants, but if its worst case is order of n square. Fortunately, the worst case is rare enough so that the speed advantages works o- overwhelming amount of time, and it is order of n log n on average. So in best case, average case, as well as in worst case, the quick sort time complexity is n log big O of n log n for given n elements. Any doubt? In quick sort, here like merge sort, we use the divide and conquer technique. In quick sort also divide stage is there, conquer stage is there, and combine stage is there. In divide stage, partition the given array of A of P2 or into two subarrays of P2 Q minus 1 and Q plus 1 to or. So in the pivot position or in the midpoint position, we are dividing the given array such that each element of A PQ minus 1 is less than or equal to A of Q. Here P is the first index position, R is the last index position, and Q is the midpoint, or we can say it is the pivot position of the given array. In the conquer stage, sort the subarrays of A of P to Q minus 1 and A of Q plus 1 to R by recursive calls of quick sort. So we are in the pivot position, we are dividing the array into two sub of, and we will solve the subarrays with respect to the relative position of Q minus 1 and Q plus 1 to R using the recursive call only. Then you combine the partitioning and recursive sorting, leave us with a sorted array of P to R. No work needed here. So divide, concur, and combine the solutions. An obvious difference is that we do not do most of the work in the divide stage with no work with the combined stage. So while dividing the given list of n numbers only, we have to be very cautious because with respect to the divide position, the subarrays are sorted. Say for example, in quicksort also, same as like merge sort, the pseudocode is the quicksort is our algorithm name. To the algorithm, we are passing the three parameters. A is the matrix and P is the first index and R is the last index position, lower bound and the upper bound. If P is less than R, Q equal to partition of AP R. To partition the given array in the pivot position, where the array starts from P and ends from Q, and we are using a temporary variable called Q. Then you call the recursive call of quicksort of A, comma, P, that is the starting index Q minus 1, the midpoint minus 1. Then recursively call one more quicksort of A, Q plus 1, comma, R. So the divided two subarrays are sorted and we are merging to get the solution. So this algorithm is almost same as the merge sort algorithm. This is your algorithm. The same way, if you take the quick sort merge sort algorithm also, almost same. Any doubt with respect to quick sort and merge sort? So in the merge sort also we are passing the array and the P and R, where P is the zeroth index, R is the size of the array. Here also quick sort also we are passing the same array of n numbers P comma R, where P is the zeroth index, R is the last index position. Then we are checking if there are elements in the array. If there are some elements in the array, then only we can perform or call the recursive call of merge sort means merge sort of APQ. Quick sort means quick sort of APQ minus 1, APQ plus 1 to R. Any doubt? The meeting will end in another 3 minutes. All of you join back. Any doubt in the pseudocode of quick sort? And in the quick sort, we are using a partitioning algorithm. The partitioning algorithm is given separately. So in the partitioning algorithm, we are taking the array P and R, x equal to A of R, the zeroth index position. That is R is the size of the array, last index position minus I equal to P minus 1 for j equal to P2 R minus 1 if A of j is less than x. So within the I is taken as p minus 1. So p minus 1 means the previous index position. For j equal to p to r minus 1. So from p to r minus 1, we repeat the process. If a of j is less than or equal to x, then I equal to I plus 1. So we'll compare the a of j, where j is the p is the first index position. Then we will compare the first index position content is less than or equal to x, where x is the pivot element or the place where we are going to divide the given array into partitioning two partitions. If the condition is satisfied, then increment the I value, exchange the A of I with A of j. A of I is your p minus 1, A of j is your current j index position. Then exchange A of I plus 1 with A of r. Where A of r is the what is A of r? What is the r index represents?
Length of the array
Hmm? What is the r
and the
index?
length of the array.
Yeah, the length of the array. Then return the I plus 1, the position where we are going to partition. So any doubt in quick sort? Within the quick sort, we are calling the quick sort two times for the subarray 1, n by 2, n by 2. And before that, we are calling the partition. The partition takes care of dividing the given array into two n by 2 subarrays. The meeting will end in another 1 minute. All of you join back. Here, the particular from this diagram, you can easily understand the quicksort algorithm is given, the initial input, and using the partition, they are partitioning the given array into subarrays with respect to the pivot element. So the meeting will end now. All of you join once again.